this video, let's take a look at opposite values together. And more specifically, instead of just looking at integers like in the last video, let's go ahead and take a look at rational numbers. So we're going to include fractions and decimals. All right, for number one, we have point A, so we're going to go ahead and find that on the number line. Now A is going to be located right over here. Now if we can see that this is 0 and this is 1, it looks like H is going to be halfway between them, which means that this tick mark is going to be 1/4, this would be half, and this would be 3/4. So for A, we're typically going to use fractions over decimals, so I'm going to go ahead and use fractions. And so for A, we're going to say that's going to be located at 3/4. All right. Now if we take a look at B, where is B located? That looks like it's right over here. So if this is 1 and this is 2, B looks like it's exactly 1.5. So I'll go ahead and write parentheses here and then write 1.5. Okay. If we took a look at C, C is down here. It's located between -2 and -3. So here's -2.25, -2.5. This is -2 3/4. So let's go ahead and write that in. It's going to be -2 3/4. All right, now what about D? Well, D is located over here. If this is -1, this must be -1 1/4. So I'm going to put that for D, -1 1/4. Okay, now what about for E? E is located over here. It's in the positive direction. So here's 2. This would be 2.25. This would be 2.5. Okay, so for E here, let's say that's going to be 2 1/2. Let's go ahead and put that just like this. For F, that's going to be, well, here's 0. F is just one tick mark below, so it must be -1/4. So we're going to go ahead and write -1/4, and that's going to be where F is located. For G, that is down here. So here's -2. This must be -2.25, a little more negative. So -2 1/4. It's the same thing. And then we have H here. So H is located right over here. So here's 0. This must be 1/4. This must be 2/4, also known as 1/2. So H is at +1/2. Again, if you wanted to use decimals, feel free to do so, but in general, we should try to practice using fractions. So I'm going to go ahead and do that for all of these. All right, now let's go ahead and take a look at plotting some of these on a number line. So let's see, for I is located at 2.75. So this is a decimal, right? So this one's we can practice some decimals here. So let's see where 2 is. 2 is right here, 2.25, that's 2.25, 2.5, and then 2.75. So I'm going to go ahead and put this right up here. This is going to be, what we're saying is I, okay? Now what about J? J is 1/4, so that's going to be a fraction now. So here's 0, so 1/4 must be just a little bit higher than that. So let's go ahead and put a dot here and then put a J. Now for 11, we have K, which is -2.5. So here's -2, here's -2.25, here's -2.5. So let's go ahead and put this dot right over here, and this would be K. For 12, we have +2.25, or 2.25. So here is +2. But 2.25 is just 2.25, so it's one tick mark above that. So let's go ahead and say this is going to be L. All right, so that's 2.25. For M, we have 1 3/4, so here is going to be 1. Here's 1 1/4, 1 2/4, here's 1 3/4. So right over here is where we're going to say M is. For 14, we have N, which is -0.75, or -3/4. So here is 0, this is -0.25, -0.5, -0.75. So right over here, this is where N is going to be located. All right. For O, it's +1.75. Let's go ahead and see where that's going to be located. Actually, I think that one's actually going to match up with one of these other ones here. So let's see. It looks like we have 1 here. This is 1.25, 1.5, 1.75. So O is actually going to share the same dot as M here. Okay. And then for 16, we have P, which is -3/1. -3/1 is just -3. So 3/1 as a whole number is just -3. So let's see, that's going to be exactly where -3 is here. So I'm going to put a dot and say this is going to be P, and I'm going to write that on the left side here where I have a little more space. Alrighty, for this next set of problems, let's go ahead and rewrite each of these fractions, anytime we see a fraction, let's rewrite it as a decimal, and then we're going to use an inequality to compare the two values after that. So no matter what, we're going to turn these fractions into decimals. So for this 1/5 here, 1/5 technically means we are doing 1 divided by 5. So let's go ahead and do 1 divided by 5 here. 5 fits into 1 0 times. So we're going to go ahead and put a decimal, and a 0. And how many times does 5 fit into 10? Well, it fits in 2 times. So 2 times 5 is 10. We have a remainder here of 0. So for this first decimal, we just have 0.2. Let's go ahead and write 0.2. And then what about the second one here? Well, we have 1/4, which really just means 1 divided by 4. And so if you know these decimals, you can just write them down. But if you don't, we should go ahead and do the division here. So 4 doesn't go into 1, but 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is going to be 2. We can add another 0 and bring that down. So 4 into 20 is going to go in 5 times. 5 times 4 is 20, and the remainder here is going to be 0. So we have 0.25. That's going to be 1/4. Now, for comparing these, we should just go ahead and add extra zeros on. So this is really just 0.20. And so 0.20 or 20 hundredths, that's going to be less than this 25 hundredths. So this is going to be less than. So we're going to say 1/5 is less than 1/4 when we compare their decimals. For number 18, we have the opposite of 3.9. This is just going to simplify to just 3.9 or 3 9/10. Now, what about this other fraction over here? We want to go ahead and turn this into a decimal. So as an improper fraction, this is really just saying 3 times 4 is 12 plus 3 is 15. So this is really just 15/4. So looking at this as a long division problem, this is 15 divided by 4. So we can go ahead and write it just like this. 4 goes into 15 3 times. 3 times 4 is 12. And our remainder here is going to be 3. Then we have a decimal, and a 0. Bring that 0 down. 4 into 30 is going to be 7. 7 times 4 is 28. 30 minus 28 is 2. We can add another 0 and bring it down. Now 4 into 20 is going to be 5. 5 times 4 is 20. We have a remainder here of 0. So for this one, we have 3.75 or 3 75 hundredths. And we can add a 0 here, so this is 3 90 hundredths. So we consider that 3 90 hundredths would be greater than 3 75 hundredths. So we can go ahead and put a greater than symbol in between here. For 19, we already have a decimal on the left side, so we have -2 and 2/10. Let's go ahead and just write that down. On the right side here, we have -2 1/4. Just ignore the negative for a moment. To turn this into an improper fraction, 2 times 4 is 8, plus 1 is 9. So this is the same thing as 9/4. So let's go ahead and figure this out as a decimal. So it's 9 divided by 4. 4 fits into 9 2 times. 2 times 4 is going to be 8. We have a remainder here of 1. We can do decimal, 0. Bring the 0 down. 4 into 10 is going to be 2 times. 2 times 4 is 8. And then 10 minus 8 is going to be 2. And add another 0 and bring it down. 4 into 20 is going to be 5. 5 times 4 is 20. So we have a remainder here of 0. So this is going to be -2.25 or -2 25 hundredths. Comparing that with -2 and 20 hundredths, well, we can see here that -2 and 20 hundredths is going to be greater than -2 and 25 hundredths. For number 20, we have -5.9, so that's already a decimal. So let's go ahead and just leave that alone for now. But what about this fraction to the right? We have -5 and 7/8. Again, just ignore the negative for now. Let's turn it into an improper fraction. So 5 times 8 is 40 plus the 7. So this is going to be 47/8, right? That's what it is, improper fraction. So this really just means 47 divided by 8. So let's go ahead and do that. We have 47. Let's divide it by 8. 8 goes into 47 5 times. 5 times 8 is 40. If we subtract here, we got a remainder of 7. We can go ahead and do decimal, 0. Add the 0 and bring it down. 8 into 70 is going to be 8 times. 8 times 8 is 64. We have a remainder here of 6. Add another 0 and bring it down. 8 into 60 is going to be 7 times. 7 times 8 is 56. If we subtract here, the remainder is 4. We can add another 0 and bring that down. Now 8 into 40 here is going to be 5 times. 5 times 8 is 40. You can see there's a remainder of 0. So this decimal is negative. It's going to be -5.875 or -5 and 875 thousandths. Let's go ahead and add 2 zeros here so we can accurately compare these. -5 and 900 thousandths is definitely going to be smaller than -5 and 875 thousandths. So this is going to be a less than. For number 21, we have 4.3, so that's already decimal. Let's go ahead and just leave that alone for now. Then to the right, we have this negative 4 1/3, so it's the opposite of the opposite of 4 1/3. So that's really just 4 1/3, and it's positive. Now, as an improper fraction, 4 times 3 is 12, plus 1 is 13, so this is 13/3. So let's go ahead and see if we can turn this into a decimal. So let's go ahead and take 13 and divide that by 3. So 3 goes into 13 4 times. 4 times 3 is 12. We have a remainder of 1. New decimal, 0. Bring down that 0. 3 into 10 3 times. 3 times 3 is 9. You can see here the remainder is going to be 1 again. So we have a 0 and bring it down. It's going to be 10 again. So you're going to notice that this is going to be a 3, 3, 3, 3, 3. It's going to go on forever. All right. So you can see the remainder is 1. It's just going to be 3s forever and ever and ever. So we're going to say 4.3. I'll just put a couple of them, but it's 4.33, and it keeps on going. To compare these, you can see that the one on the left is 4.3, technically has a 0 after it. So if you're comparing these 4 and 30 hundredths and comparing that with 4 and 33 hundredths, if they're both positive here, this is going to definitely be less than, right? So this is less than. So just keep in mind that repeaters just have 3s on forever, but the 4.3 over here on the left just has 0s after that. So the one with 3 repeating is going to be bigger, or the 4.30 on the left is smaller. All right, for 22, we have -2 and 3/20. We're going to go ahead and turn this into a decimal. So let's go ahead and do some long division for that. So I think 2 times 20 is going to be 40, 40 plus 3. So this is really the same thing as 43 over 20, right? It's a -43 over 20. But to turn this into a decimal, let's go ahead and do that division. So I'm going to do that on the side here. I'm going to do 43 divided by 20. Now 20 goes into 43 2 times. 2 times 20 is 40. 43 minus 40 is going to be 3. We do decimal, 0 here. 20 goes into 30 one time. 1 times 20 is 20 with a remainder of 10. Let's go ahead and add another 0 and bring it down. Now 20 into 100, that's going to be 5. 5 times 20 is 100. And this remainder is 0. So this decimal here is going to be -2 and 15 hundredths, or -2.15. And what about this other fraction? Let's go to impropers first. So 2 times 6 is 12, and 12 plus 1 is going to be 13. So this is -13 over 6, right? Now what is that as a decimal? Let's do 13 and divide that by 6. So 6 goes into 13 2 times. 2 times 6 is 12 with a remainder of 1. Decimal, 0, bring that 0 down. 6 into 10 is 1 time. 1 times 6 is 6. The remainder here is 4. You can add another 0 and bring it down. So 6 into 40 is 6 times. 6 times 6 is 36. Notice how the remainder here is going to be a 4 again. So if we add another 0 and bring that down, this is actually going to keep going as 6s forever. So it's going to be 2.1, and then it's 6, 6, 6, 6, 6 forever and ever and ever. So it's a repeater. So I'm going to say -2.16 with a line on top of it, right? Now this is -2.15, this is -2.16, so the 6 is definitely going to be creating a number that is a little further away from 0. So -2.15 is actually greater because it's going to be closer to 0 or to the right on the number line. All right, here is 23. For these problems, we're just going to use our knowledge of opposites and rational numbers to answer the following question. So we have a little multiple choice question here. For 23, it says, which of the following is true? So I'm going to go ahead and just say, well, I know here that 6.5 is the same thing as 6.50. And then if we take a look at this 25 fourths, we can say that that 25 fourths, if we go ahead and divide that down, 25 divided by 4 is going to be 6 times 4 is 24 with a remainder of 1. We can do decimal, 0 here. And then 4 into 10 is 2 times. 2 times 4 is 8. 10 minus 8 is 2. We can add another 0 and bring it down. 4 into 20 is 5 times. 5 times 4 is 20. The remainder here is 0. So this one here is going to be 6.25. And so what we're asking is 6.50 greater than 6.25? Yeah, that is true. So we're going to go ahead and say that A is our answer here. Now, just for good measure, if we were comparing these next ones just to see and get some extra practice, this is negative 6.5, and we already know that 25 fourths is 6.25, so this would be negative 6.25, or we can add a 0 here, so this should technically be less than instead, right? So that's why this one doesn't work. Okay, just to verify that. For this next one, negative 6 is not greater than negative 5. Negative 6 is indeed smaller than negative 5, so that one definitely doesn't make sense. And then we already did the division for this, but if we have a 5 here, and then this one is going to be 6.25, well, 5 has to be less than 6.25, right? Just because the whole number is smaller. So that one definitely can't be it. So kind of nice for us. The one we just kind of started with was A, and A happens to be true. And because it's a multiple choice question, then A was the correct answer. All right, here is 24. Here we're gonna go ahead and order the rational numbers from least to greatest and then explain. So let's see, generally we like decimals, so which ones are we gonna leave alone? I'm gonna leave this negative 6.35. It has 2 decimal places, so I'm just gonna go ahead and make this decimal at the end also have 2 decimal places. So we already know between these two which one is smaller and bigger, hopefully. This one's smaller and this one's bigger, but we do wanna make sure we know these other ones. So let's go ahead and take a look at this negative 6 1/4. If you want to turn that into a decimal, let's go to an improper fraction first. So it's negative 6 times 4 is 24 plus 1 is 25 over 4. Then going ahead and doing this long division, this is 25 divided by 4. 4 goes into 25 6 times. 6 times 4 is 24. The remainder here is going to be 1. We can do decimal, decimal, 0 here and bring this down. 4 into 10 is 2 times. 2 times 4 is 8. 10 minus 8 is 2. We can add another 0 and then bring that down. 4 into 20 is 5 times. 5 times 4 is 20. The remainder here is going to be 0. So this is going to be negative 6 25 hundredths, or negative 6.25. One more here. Let's go ahead and take a look at this negative 6 1/5. So as an improper fraction, 6 times 5 is 30 plus 1 is going to be negative 31 over 5. And so what is that going to be as a decimal? So we can just ignore the negative for a moment and just do 31 divided by 5 here. 5 goes into 31 6 times. 6 times 5 is 30. Remainder here is 1. Decimal, decimal, 0. Bring the 0 down. 5 into 10 is going to be 2 times. 2 times 5 is 10. Remainder here is 0. So for this one, it's going to be negative 6.2. But let's go ahead and just add a 0 so everything has the same decimal place values here. So we have a few decimals here. We have negative 6.25, we have negative 6.35, negative 6.20, and negative 6.10. Now they're all negative, so the one that's kind of the biggest negative is the smallest. Now notice how they're asking us to rank them from greatest to least. So we're actually looking for the one that has the smallest number but is the greatest value, because these are all negative, so everything is kind of flipped here. So in terms of the greatest, this one will be the greatest number here, negative 6.10. It would be to the right on a number line. Then this would be the next biggest, this negative 6.20. Then this would be the next biggest, negative 6.25, and then this is technically the smallest, negative 6.35. So if we have to order those original numbers, so writing the original values that we were given, negative 6.1 is the greatest value that we have. The next greatest one is going to be this negative 6 1/5. Make sure we write the original numbers that we were given in the problem. This is going to be greater than the negative 6 1/4, negative 6 1/4. And then finally, this is going to be greater than that negative 6.35, or negative 6 35 hundredths. So from greatest to least, this would be the order of these rational numbers. Here's 25. For 25, Benny says that there are infinitely many rational numbers that are between 0 and 1. Do you agree or do you disagree? Now between 0 and 1, let's think about some fractions here. Well, you could definitely say something like 1/2, you can say something like 1/3, you can say something like 1/4, and you can say something like 1/5, right? Now, can you do this forever? Can you basically keep creating fractions that have greater and greater denominators? And would these fractions all be equal to between 0 and 1? Well, I'd argue, yes, you can keep creating more and more, and that's only with the denominator of 1. You can also create fractions that have 2 on top, like 2/3, right? You can also say something like 2/4, which is just a half, but then there's like 2/5, so just for a new fraction. But there are infinitely many fractions that you can write that are between 0 and 1, as long as we keep changing those numerators and denominators. So hopefully I provided enough examples to kind of go ahead and say that. So for me, what I would say is yes, I would agree. And I would say essentially something like this, that I would agree because there are infinitely many combinations of numerators and denominators that we could choose to make new proper fractions. So we can keep changing the numerators and denominators. If it's going to be between these values of 0 and 1, all these fractions, make sure they're all proper fractions, but we can go ahead and just keep writing more and more of these proper fractions, which means there would be infinitely many rational numbers between 0 and 1. So hopefully I provided a few examples and also kind of defended my argument by going ahead and saying and giving some good logic of why I would support this. Okay, let's take a look at 26, this final question here. It says, which could be the value for m here? Now, if we take a look and see where m is located at this location here. And so it is, here's 0, right? And here's -1. So m is definitely a proper fraction that is between 0 and 1 here. So it's a -1 as well. So if it's a negative value, we should go ahead and definitely say that a does not make sense because that's positive. B also doesn't make sense because that's positive. Now, potentially it could be C and it could be D because it's negative. And let's see here. So if we have 0, this is -1/4. This must be -1/2. So it's got to be more negative than -1/2. So let's see here. It's got to be more negative than -1/2. Well, this one over here is less negative, right? So that's -1/3 is definitely smaller than 1/2, okay? And so that leaves us with only one answer here, and that's going to be C. C is going to be -2/3. So hopefully that makes sense because here's -1/2, here's -1. -2/3 would fall between -1/2 and -1. So if you wanted to figure out the decimal for this one, -2/3 is just -0.66666 repeater, and a -1/3 happens to be -0.33333 forever repeater, all right? And so -1/3 would probably lie somewhere around here. This is where -1/3 would be, and a -2/3, that would be right over here where m is. So that's the only one that really makes sense here. All right, so there you have 26 different practice problems, kind of getting the hang of dealing with some negative fractions and decimals, or we also call these rational numbers because they include integers as well. But hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.